Good morning, dear students. Welcome to the class on pre-stressed concrete. We are in Unit 2. We are solving for analysis of pre-stress topic. And we have seen an example in the last session, how to analyze a pre-stressed concrete beam. This session, we will take up one more example, which is also from the previous JNTUK papers. Right, let us see the example. So this is a question given in the example university paper, like a rectangular concrete beam of cross section 30 centimeter deep, 20 centimeter wide is pre-stressed by means of 15 wires of 5 mm diameter located at 6.5 centimeters from bottom, and also 3 wires of same diameter 5 mm diameter 2.5 centimeters from top, and stress in steel as 840 Newton per mm square. It's not Newton mm square, it is Newton per mm square. Calculate the stresses at the extreme fibers of the midspan section when beam is supporting its own weight over a span of 6 meters. That is one part of the question, say part A. If a uniformly distributed live load of 6 kilonewton per meter is imposed, evaluate the working stress in the maximum working stress in the concrete. That is part B question. So when there is only dead load, what are the stresses? When there is live load also, what are the stresses? This is the question. And the point here is you work out this problem with this 20 centimeters as width, taking this example what I'm going to give you with B 15 centimeters. Okay. So you work out for 20 centimeters. I'll work out for 15 centimeters. Right. So remaining data is same. Okay. Now the point here is you have wires at different locations. Some wires are at bottom, some wires are at top. So you have to locate the CG of the wires first. Then only we can proceed for finding stresses, because if you want to find the stress due to pre-stress like PE by Z value, to take E value, you have different values of E here. For bottom wires, E is different. For top wires, E is different. So you have to have a common eccentricity value. So to do that, what you need is to locate CG of the wires, okay, steel wires, HDS wires. So that's the first job to do. So you have to find distance of CG of pre-stressing force, okay, from bottom, okay, right. So from bottom, in the sense I am taking the reference line at bottom, is the reference line, and I'm going to use the centroid formula for finding this to locate CG of the wires. So just a modification to centroid formula. Now we are working out in the numbers. So N1 Y1 plus N2 Y2 divided by N1 plus N2. This is the formula used, okay, for finding the stresses, for finding CG value. So y bar is equal to, now N1 means bottom wires number, 15 numbers. 65 mm is the Y1 distance. This is y1 distance. N2 top bars number 3 and y2 from reference line. This is y2. Okay, so this is y1, this is y2. So this red line indicates here there are 15 number of bars along this line. Okay, that is what is instead of putting no dots of 15 number. So I've just drawn a red colored line which indicates the 15 number of bars. Okay, right. So divided by n1 plus n3, which worked out to be 100 mm. That means at a distance of 100 mm, means say this is 150 from center to bottom, 150. So total 300. This is 150. So make this into 3 equal parts. So this is each one is 50, 50 and 50. So at 100 from bottom you have CG of wires. This is CG of wires. So eccentricity means what? From center of cross section of concrete, location of tendons. So this is E value. So which means d by 2 minus y bar, or else this is 150 minus this is 100. 150 minus 100, that is 50. Okay, so 50 mm is the eccentricity of high tension steel bars. Right, this is the first job. Next, what is a pre-stressing force value, P value? So you have stress value into area of wire is pi d square by 4. Each diameter is 5 mm, same diameter. And total 18 number of bars are there. So that will work out to be 296.881 kilonewtons. So finally, in newtons, 2.97 into 10 power 5 newtons. And you need Z value for finding stress. So Z means I by A, you need I by Y. So area is required. So which is used to for finding the load value. Right. So I by Y. So you need I value, moment of inertia, B H cube by 12. As I told you, I use B as 150 and you use 220 centimeters. Okay. So that is working out to be 337.5 into 10 power 6 mm power 4. Z means I by Y. Y is nothing but, say, this is the cross section. So location of CG at center, because it is rectangle, is 150. Okay. Either Z is you use I by Y, or else PH square by 6. Y means the distance of bottommost fiber from CG is 150. So I means 337.5. It's like 337.5 10 power 6 divided by 150. So will be 2.25 10 power 6 mm cube. Okay. I have used here BH square by 6 as the formula. Dead load, you have to calculate it from gamma given to you, which is kilonewton per meter cube into meter square in terms of area. Meter square, if you add, it will become kilonewton per meter. So multiply gamma with cross section will give you weight of the beam per meter. Okay, this gamma value kilonewton per meter cube. Okay, and this is meter square, right? So finally it will be kilonewton per meter, 1.08, that is dead load value. And bending moment due to dead load, WL square by 8, that is kilonewton meters, 4.86. Live load is already given to you, 6 kilonewton per meter. WL square by 8 again will give you 27 kilonewton meter is the live load bending moment. Now let us see how to find stresses. Okay, so stresses due to pre-stressing force, we have calculated pre-stressing force total value divided by A, P by A will give you this one, 6.6 Newton per mm square. And bending stress due to pre-stressing force is like PE by Z, P value, E value and Z value. Substitute for all those values which we have worked out. Total P is 2.97 10 power 5. E is 50 mm. Last slide you have worked out 50 mm from CG of the tendons because they are at different locations. So PE by Z will come around 6.6 and dead load moment is already worked out by you, 4.86 kilonewton per meter. So convert that into Newton mm, that is kilonewton meter it was. So kilonewton meters is converted to Newton mm divided by mm cube, that is 2.16 it is. Same way live load bending moment also convert into Newton mm by multiplying with 10 power 6 by Z is 12, working out to be 12 Newton per mm square. Okay, right. Now taking up the formula for each case of the question. So first case, say let us, first part of the question is to find out the extreme fiber stresses only due to own weight. Okay, own weight, when own weight acts means along with pre-stress, when own weight is acting means what, this part of the formula shall come into picture, top, bottom. Okay, so bottom stresses, you just take only this part of the calculation. So what is it? 6.6 plus 6.6 minus 2.16. Okay, so let us see that how much it is. So 6.6 plus 6.6 minus 2.16 is 11.04 at bottom. Okay, 11.04 at bottom. 11.04. What about top? This part of the equation. This is direct stress from pre-stress, bending stress from pre-stress, and this is stress from dead load. Okay, you see stress from dead load is 2.16, right? Okay, now this is 6.6 minus 6.60 plus 2.16. So this is also positive 2.16. Right, so final stress diagram is like this is 11 compression and 2 compression. Roughly, I am working out values. So 11.04 compression and 2.16 compression is 2.16 compression. So total compressive stress when it is only self weight is acting. Okay, this is one part of the question. The other part of the question solution is second part, when you have UDL live load 6 kilonewton per meter, what is the maximum stress in the concrete? Okay, so now the live load stress also you have to consider total now. So full formula. Now consider bottom, add the stress from live load is 12, so bottom tension, so I use minus 12, top compression plus 12. So finally it comes to bottom minus 0.96, it is inferior means bottom 0.96 tension top 14.16 compression. So this 11.04 has become 14, and this 2.16 compression has become a little negative here, very very minute value of negative. So this is compressive stress, which is 14.16. This is the final stress diagram, and a tensile stress of 0.96. So very little negative value. Okay. So this is when live load is acting 6 kilonewton per meter. Okay. So if the live load is increasing, the compression is becoming tension. Okay. And the compressive stresses will go on increase. Tensile stresses also go on increase when you have live loads, more and more live loads. Okay, so this is how we have answered two parts of this question. And you work out the same problem with the width as 20 centimeters instead of 15. Okay, work out for 20 centimeters. Also, see the solved examples which are available in the prescribed textbook from example 4.2 to 4.5. You practice them so that more and more you practice, and you will get the confidence in solving such analysis problems, right? Okay, right. We'll take up the another concept of finding stresses like pressure line concept in the next session. Thank you.